All right, so we are on number 32, part C, which unfortunately is from the last video. So I'll just recap where we were. We had just found that f inverse of C is equal to negative 100C over 6C minus 1.2. And we're asked to find f inverse of 0.15. So just a note, that is a value of C. And so I'm wanting to find for what concentration, I'm wanting to find when is the concentration equal to 1.5. So I'm looking for a T equals, the answer for that is going to give me a time, right? When I plug in a concentration, I get a time. So negative 100 times 0.15 over 6 times 0.15 minus 1.2. Okay, that gives me 50. So what that means is that after 50 minutes, the concentration will be 0.15 pounds of salt per gallon. Moving on to number 33. It says a transformation takes a function and creates a new function by giving formulas in the first column. Assume the point 12, negative 6 lies on the graph of f. Match the formula to a correct interpretation and the coordinates of the point on the new graph. Okay, so if we are multiplying the x by 3 on the inside of the parentheses, that is going to be a horizontal compression by a factor of 1/3, so that would be a B there. And if we want to compress horizontally by a factor of 1/3, that means that's impacting the x coordinate. So the x coordinate is going to be multiplied by 1/3. So if we multiply the 12 by 1/3, that's going to give me 4. And then the y coordinate is unaffected by this shift here. So 4, negative 6. Okay. H of x is 3 times f of x. So that's going to be multiplying the y coordinate by 3, which would be a vertical stretch by a factor of 3. So that one would be C. And so if I am multiplying the y coordinate by a factor of 3, the x coordinate will stay the same, so just the 12. And then the negative 6 will be multiplied by 3, so negative 18. Okay. The next one is f of x minus 3. That would be a shift in the x direction, right 3 units, so that's E. So I'm going to take the x coordinate and I'm going to add 3 to it. So 12 plus 3 is 15, negative 6. Okay. The next one is f of x minus 3. That would be a shift down 3 units. So that's H. So then I would do the y coordinate will be, I'll subtract 3 from the y coordinate. So 12, negative 9. And then for the next one, f of x plus 3, that's a shift to the left by 3 units. So that is f. And so if I go to the left, then I will be subtracting 3 from the x coordinate. So that'll be 9, negative 6. And then on the next one, f of x plus 3, that is a shift up 3 units. So that will affect the y coordinate. So that was G. So that will be 12. And then if I add 3 to the y coordinate, I'll have negative 3. All right, problem 34. Find a formula for the function g as a transformation of the function f. Okay, so find a formula for the function g as a transformation of the function f. Okay, so g is equal to, g of x is equal to is it x? Yeah. Okay, so a couple of things we might notice. One is that the maximum here is 1, but then here is 3. So I have a vertical, stretch by a factor of 3. So that's going to put a 3 in front of my f of x. Okay. The other thing I might notice is that my function went from 0 to 8, my original function, but my new function goes from 0 to 4. And so I have compressed horizontally by a factor of 1/2. So this would be 1 over 1/2, which turns out to be 2. So if you do 1 divided by 1/2, you'll get 2. So the final function should be 3f of 2x. All right, let's do number 35. Write a formula that takes the function f of x equals square root of x and transforms it as follows. So f of x equals square root of x. Okay. So what are the transformations given here? First, I'm going to reflect across the x-axis. So that would be a flip over the x-axis. So that would be a negative out front. Next, I want to shift up 5 units. So that'll be a +5 on the outside. Then I want to horizontally compress by a factor of 1/3. So that would be a 3 on the inside with the x. And then I want to shift to the right 4 units. So I need to do, to the right would be -4 on the inside. So that should be it. F of x, let me write it all in one color for those of you that are annoyed by the color change. 3x minus 4 plus 5. Okay. Number 36. A function f has domain -20 to 15 and range -1 to 12, and the point -5, 7 lies on its graph. The function h is a transformation of f given by that. Okay, so we want to transform everything. So to describe the transformations in the correct order. Okay, so let's start with our the vertical stuff, I guess. So vertically, I see that there is, if I look kind of at the stuff that's transforming on the outside, I have this 3 here and this +2. So what I have here is a vertical stretch by a factor of 3. That's the first one. The second one is a vertical shift up 2 units. Okay. Then I want to look on the inside and see what's happening. On the inside, I see these 2 things. So what is that? That is a horizontal compression by a factor of 1/5. And then the last one is a horizontal shift left 6 units. Okay. And so we can look at the domain and range. And so I can see that the domain will be impacted by these 2, and the range will be impacted by these 2. So if I look at the range, oh, whoops, did I do that backwards? Yeah, no, it's okay. So the range will be, I'm going to multiply the y coordinates by 3 and then add 2. So this is telling me that I'm going to multiply y coordinates by 3 and then add 2. So what does that do to my range? My range is going to be, so if I multiply by 3, I'll get negative 3, 36. And then if I add 2, I'll get negative 1, 38 for my range. And for the domain, this means I'm going to multiply the x values by 1/5, and then I'm going to subtract 6 from my x values. Okay, so if I go to my domain, if I multiply the x values by 1/5, that would give me negative 4, 3. Oh, is that a bracket or parentheses? Hang on, let me see. Oh, it's a parentheses, okay. And then I'm going to subtract 6 from both of those. So I'll get negative 10. 3 minus 6 is negative 3. Okay, so that's my new domain. So, sorry, I'll erase these intermediate steps there. Okay. And then I want to name a point that lies on the graph. So we're going to do the same thing. So my point is negative 5, 7. So the negative 5, I'm going to do the same thing, multiply by multiply by 1/5, and then subtract 6. So if I multiply that by 1/5, I'll get negative 1. If I subtract 6, I'll get negative 7. And for the y coordinate, I start with 7. I'm going to multiply it by 3, so that's 21, and then add 2, so 23. So that's the point on my line, or on my new function. Okay, next one. Okay, for the next one, it says, determine algebraically whether the function is even, odd, or neither. So just a quick reminder, the definition of an even function is if f of negative x is equal to f of x. A function is odd if f of negative x is equal to the negative of f of x. And a function is neither if it doesn't satisfy either of those two. Okay, so let's take a look at f of x here. So what is f of negative x? Well, I'm going to take that and I'll do negative x squared plus 1. Well, I know that negative of x squared is equal to x squared. And if I compare that to my original function, that's equal to f of x. So it satisfies the definition of an even function. Next it says an even function is defined an even function is decreasing and concave down in the first quadrant. What can you say about its behavior in the second quadrant? So it's decreasing and concave down, like that. And so what that means is that for any x value, the negative x value is going to have the same y coordinate, right? So it should match up for every x value here. We should have the same thing here. So it's going to have reflection symmetry around the y-axis. So what that's going to mean is that in the second quadrant, it's going to be concave down, and it will be increasing. Okay. So if I just draw it out, you can kind of see what the picture looks like.